Now let's discuss the symptomology associated with tracheal mites. Unfortunately, tracheal mite infestations can be very difficult to recognize. There are three primary symptoms associated with tracheal mite problems in your colonies. Two of those occur in the colony, one of those occurs outside the colony. It's important to remember that tracheal mite problems typically are at their peak in fall and winter. Keeping that in mind, you'll appreciate the first symptom, a disorganized cluster of bees. In fall and winter, when cooler temperatures arrive and bees are supposed to be clustering in order to keep warm, the presence of tracheal mites at high numbers can actually cause the bees to not cluster adequately. So on a cool day when you go into the bee colony, the bees may be walking around and not clustered at all. So that is one symptom. The second symptom deals with the anatomy of the honeybee. You probably recall that bees have four wings, two wings on either side of the body. The front wing is connected to the second wing or hind wing on each side of the body by little hooks called hamuli. As such, when bees fly, those wings move in tandem. Well, in tracheal mite infestations, those wings can become unhooked and you can see disjointed wings, or K-wing, because when you look at a bee, the way the wings are spread out on the right side or the left side of the body, the bee looks like the letter K. The third symptom of tracheal mite infestations actually occurs here on the ground in front of the colonies. Bees heavily infested with tracheal mites will wander away from the nest, and you can actually find them on the ground crawling up blades of grass in front of the colony. The problem with these symptoms are they're not unique to tracheal mites. Many different bee diseases and pests can cause any one of these symptoms. So the best way to diagnose your tracheal mite problem is to actually collect a sample of bees that you suspect have tracheal mites. It's best to collect a sample from the bees wandering around on the ground outside the colony because they're the ones most likely to have tracheal mites. You'll need to collect 50 to 100 bees, put them in a jar of alcohol, isopropyl or rubbing alcohol is okay, and send them to your local county extension office for identification. There, the county agent or perhaps a bee scientist will dissect the bees and look for the presence of tracheal mites. So what happens to that sample of bees that you send in to your county extension agent? Well, it's very likely that he or she is going to forward that sample over to a state apiarist like myself. In order to do the dissections properly, though, we have to have the appropriate tools. First of all, we need a dissecting microscope. This dissecting microscope here has the ability to magnify things from 7 to 40 times. Typically, though, we like to look at bees under the microscope at about 20 or 30 power when we're doing tracheal mite dissections. Second, you need 2 pairs of forceps. It's very important to note that these forceps have very small tips. Everything is larger under a dissecting microscope, so if you get a pair of regular forceps, the tips are going to be far too big for you actually to be able to do any dissections. You do need 2 pairs because you will be working with both hands while you're dissecting your bee. Secondly, you need a little tray like the petri dish I have here that has some medium in the bottom that permits you to stick insect pins into. Here we just have a petri dish with beeswax that we melted to form the base. Notice the beeswax doesn't go all the way to the top of this petri dish because we're going to put the bees in here and flood this area with alcohol. So we want to make sure that there's some area on top of the wax that we can put alcohol. You'll also need some sort of improvised pinning device. This is simply a pencil that we broke in half and we stuck 2 tiny insect pins in the eraser. The 2 pins permit us to pin the bee down to the wax in the petri dish. If you only have 1 pin to pin the bee, as you're working with the bee is going to pivot around that pin and make it very difficult for you to keep the bee still. Finally, we have a container of alcohol. When you put the bees into your petri dish, you're going to flood that area with alcohol, not water. If you use water, there will be tiny bubbles that form all over the surface of the bee and make it very difficult for you to see. So we simply use alcohol. We put the bees in here, we flood the area, and that makes it where we can work with the bee a lot better. Now that you have the proper equipment, you can actually dissect your bees yourself. But in the event that you don't, let me just share with you exactly what happens as we receive your tracheal mite samples. First, we will remove about 10 to 20 of the bees that you sent us from the alcohol sample and put them on our Petri dish or wax surface. Next, we will flood the Petri dish with alcohol like I've discussed before to completely cover the bees. Once this has occurred, we will actually pick up one of your bees and grab her by her wings. Next, we'll use our forceps to remove the abdomen from the bee. This is actually a very important step because if you leave the abdomen on the bee, as you work with that bee under the microscope and you're pushing down that abdomen, honey or nectar can come up from the abdomen through the thorax and cloud your field of view. Once you remove the abdomen, take your insect pin and push it through the bee at about a 45-degree angle relative to the legs. After you've done this, you can take your bee and pin it into the wax medium in your Petri dish. Next, take your forceps and looking through the microscope, remove the bee's head. Now usually the bee's head will come off with the front legs of the bee. This is important. If it does not, you'll actually have to go in there and remove the front pair of legs from the bee manually. Once you've done this, you can see a little bit of the white tissue that's on the inside of the bee. You're not finished though. You actually have to go and remove one more piece of the bee in order to adequately see what's going on inside of the bee's thorax. That piece is the collar, and it's a ring that runs around the perimeter of the thorax. You will grab that collar at the base of the thorax, arrowed in the diagram here, and use your forceps to pull the collar away from the thorax. You must remove this collar. You do not see enough of the tracheal system to diagnose the presence of tracheal mites while the collar remains on the bee. Also important to know is that that collar actually covers up the two spiracles on the bee's thorax where the tracheal mites first enter. So if you have a low tracheal mite infestation, tracheal mites will actually be under that ring and you can't see them. With the collar removed, you'll be able to see the tracheal mite system quite visibly. The tracheal system actually looks like the letter V turned upside down. If you look in this diagram here, you can see the trachea actually outlined. Healthy trachea are transparent. You can see through them. They're creamy in color. Low infestations to moderate infestations of tracheal mites appear as white globules present in the tracheal system. It's important to be able to distinguish these white globs from fat bodies that are also present in the thorax. At high infestations of tracheal mites, the tracheal mites actually cause scar tissue in the tracheal system like that arrowed in the trachea in this picture. The scar tissue looks black. It can completely cover trachea, and if you see this, your trachea or your bee is present for tracheal mites. I recommend dissecting up to 16 different bees, and if you find no tracheal mites in any of these samples, then you have a 95% probability that you have no tracheal mites in the colony. If your bees have 10 to 20% infestation, then you need to treat your bee colonies.